Earlier in our study of climate change, I went over many of the impacts that climate change is causing globally. In this presentation, I want to focus specifically on the impacts that climate change is having on the southeastern United States. These are the main impacts that we're seeing with a changing climate. We'll devote an entire unit to several of these topics, and so for now, I'll just touch on them briefly here. Rising average temperatures during all 4 seasons is hallmark of the climate change throughout the world and here in the Southeast. It is this added heat to the atmosphere that is causing most of the problems. But just the added heat creates its own set of problems. By now you've seen this animation from NASA of how global temperatures have risen over the past 140 years. If not, you can play the video by clicking on the image in the PowerPoint posted for this video. Notice that temperature change is uneven across the planet. Some areas have warmed significantly, others only mildly. Some have actually cooled. We have seen moderate amounts of rising temperatures here in the Southeast. Temperatures can be measured in many ways, and it's important to understand how each graph is created before drawing conclusions. This chart shows average temperatures for the lower 48 U.S. states from the period of 1895 to 2016, and only for January to December. The purple line is the average temperature as it varies from year to year, and the blue line is the trend line that best fits the purple line. As the trend line indicates, winters are getting substantially warmer. The trend would be even stronger if it was only for the past 50 years. This map shows average annual temperature changes in the U.S. from 1986 to 2016 in comparison to the average temperatures from 1901 to 1960. The greater the difference, the stronger the color. Note that the greatest warming has been in the Northeast, Northwest, and Southwest. The Southeast has warmed mildly, and there has been slight cooling in Alabama and Mississippi. These portions of the Southeast are what scientists call a warming hole, which is a spot on the planet where temperatures have been relatively stable or have decreased. The reasons for this are complex and not fully understood. But before you get excited that Alabama gets a pass on warming, you should know that the warming hole has disappeared and the warming we are experiencing now is making up for lost time. In these figures, we zoom in on the Southeast. The bar graphs show temperature trends for the region. The maps show relative changes in temperature for cities where there are weather stations. In the top figure, we see the trend for the number of days above 96 degrees Fahrenheit by decade. There's no clear trend of increase in the Southeast using this measure, which corresponds to the cooling we saw for parts of the Southeast in the previous slide. Note that the high temperatures in the first half of the 20th century are due to several decades of extreme temperatures. Now, check out the bottom figure, which shows the frequency of warm nights above 75 degrees Fahrenheit in the Southeast. Notice the strong, clear trend for more warm nights from the 1970s onward. This is more typical of temperature trends throughout the U.S. and around the world. Finally, note the caption in blue, which explains that 61% of the southeastern cities are now contending with worsening heat waves, and this is more than in any other region in the U.S. Heat waves are periods of prolonged, abnormally high temperatures. We are experiencing more of these in the Southeast in recent decades. This map depicts one from May 2019. Heat waves are times when many vulnerable populations are hard hit by climate change. Heat-related illnesses vary from sunburn and heat rash to life-threatening situations like heat stroke and heart attack. People of lower socioeconomic strata tend to be the most vulnerable to problems caused by heat waves. The poor, who do not have air conditioning, are at greater risk of heat-related illnesses. The poor with air conditioning pay substantially higher AC bills, something they can't easily afford to do. There's much more to say about the relationship between heat and health and poverty, and these topics get into issues of race. I hope to have a presentation on this topic developed soon. As I said earlier, there are many ways to measure temperature trends. This graph on the left is a measure of how long the growing season is in the southeast by decade, defined by the number of days between the last freeze in spring and the first freeze in the fall. The trend has been for an increased growing season. That means warming. This can be good for some aspects of the economy. For example, a longer growing season can mean that farmers increase their yields. However, this can be a problem for farmers that grow cool season crops, such as peaches. So the trend has been for warming so far, but what might the future bring? These maps show forecasts for amounts of warming in the US for the mid-21st century at the top and the late 21st century at the bottom. And these are for two RCPs. Recall that RCP 4.5 means that we hit peak emissions around the year 2030. RCP 8.5 is the business as usual scenario. Temperature change is depicted by a color relative to the period 1986 to 2015. Numbers next to maps indicate degree change for the southeast. Note the greater warming in areas farther north. While there will be less warming in the south will still be hotter than the north because these changes are relative to existing trends. Let's pivot now and look towards our coasts. As we pump more carbon dioxide into the atmosphere, more and more of it is absorbed by the oceans. When dissolved in water, CO2 causes a series of reactions that lead to the water becoming more acidic, and to there being less carbonate available for creatures to make their shells or their bodies. This can and will disrupt ocean food webs in several ways. Some of the plankton at the bottom of the food chain will decrease in abundance. Snails, clams, and corals will be less able to reproduce and grow. And this can send ripples all this can send ripples throughout the marine food web. It could potentially impact fisheries such as the scallop and oyster fisheries along the southeastern coasts, and potentially fisheries for some finfish that are commercially important. While we're talking about oceans, I'll briefly mention rising sea levels. We'll spend a whole class on this issue soon. Recall that sea levels are rising because of the expansion of water as it warms, and because the melting of polar ice and the melting of glaciers. All this volume of water added to our oceans is causing sea levels to rise. This is creating numerous hazards and problems on the southeast Atlantic and Gulf coasts. More about this and what we can do about it will be coming up later. Let's talk briefly now about the fate of ecosystems as the climate changes. We'll explore this in more depth later. In Earth's past, during periods of gradual climate change, ecosystems simply changed form and composition as the distributions of species changed in response to climate. Generally, when the climate warmed, the result was for ecosystems to move farther north. This is why fossils of tropical species can be found in the Arctic in rocks dating back to the PETM, also known as the Paleocene-Eocene thermal maximum. In mountainous areas, ecosystems migrated upslope to higher, cooler elevations. However, today's climate change is very rapid in comparison to many of the changes in the past, and we humans have put many barriers in place that prevent species from migrating, including agricultural areas, cities, and even interstates and reservoirs. Plus, some species simply cannot migrate because they live in specialized environments not found elsewhere. One ecosystem that is migrating is the mangrove swamps that are found in coastal South Florida and southern Texas and Louisiana. Mangroves are trees that can grow in brackish water conditions. Along most of the Gulf and southeastern Atlantic coasts, these shallow water brackish areas are dominated by salt marshes. Salt marshes are nursery grounds for shrimp, blue crabs, and several fishes, and thus are economically important. Salt marshes are depicted in the picture up at the top left, and a mangrove swamp is in the picture at the top right. Mangroves are tropical plants, and as the climate is warming, they are marching northward and replacing salt marshes. By the end of this century, it's expected that much of the southeastern coast will be dominated by mangroves. There's good and bad news here. Mangroves provide great protection from storm surges that hurricanes bring, and they offer good habitat for many species of animals. On the downside, they don't harbor all the same wildlife as salt marshes do, so we'll see populations of some species decline and possibly go extinct. And many, including myself, think that salt marshes are exquisitely beautiful ecosystems, and I don't want to see them replaced. Some ecosystems will migrate, but others may be lost entirely if there's nowhere for them to go. One that may disappear are the dune ecosystems along our coasts. The larger image here shows Santa Rosa Island just days after Hurricane Ivan struck the northern Gulf Coast in 2014. Sand dune ecosystems there were obliterated along much of the island. Coupled with sea level rise and ever more powerful hurricanes, these ecosystems may not be able to survive climate change. However, over geologic time, barrier islands can migrate, so there's a chance that barrier islands can gradually migrate inland. But that would require us to let them, and all of the coastal developments on these islands prevent sands from migrating as they might naturally. Let's turn now to a familiar aspect of the climate, rainfall. You already know that high amounts of rainfall that Alabama receives is one reason why the state has so many productive ecosystems, and including both terrestrial and aquatic ecosystems. And those ecosystems therefore sustain lots of the species that make Alabama rank so highly in terms of biodiversity. But rainfall, how much we get and when it falls, is critically important also for sustaining agriculture, our supplies of drinking water in the southeast. And because water is often used as a coolant in industry, water availability and therefore rainfall affects everything from energy production to manufacturing. This map shows total annual rainfall in terms of percent change relative to historic trends. The historic baseline is from the year 1901 to 1960, and the period represented by colors on the map is 1986 to 2015. Warmer colors show percent decline in rainfall. Bluer colors represent percent increase. First, notice that rainfall has changed dramatically in many areas of the U.S., but that change isn't consistent across the U.S. Some parts of the Southwest have seen over a 15% decline in rainfall, while the Northeast, Midwest, and parts of the South have seen substantial increases in rainfall. Let's look specifically at the Southeast. Much of Florida, Georgia, South Carolina, and North Carolina have seen a mild decline in rainfall, while Alabama, Mississippi, and Tennessee have seen mild to moderate increases. While a 5 to 10% change in rainfall may not sound like a lot, this can affect things like whether cities and farmers get enough water, or whether some agricultural areas get too much rain. And it's not just a matter of how much rain falls, it's a matter of when. These maps are from the same figure and are designed the same way. Notice that in the fall, much of the Southeast has already seen an increase in rainfall over 15% in recent decades. Meanwhile, springs and summers are drier. These changes can have dramatic impacts on agriculture. Heavy rains and waterlogged soils in fall are bad for some crops and fall harvests. And spring and summer are when irrigation needs are the greatest for farmers. Summer is also when our overall demand for water is the highest due to the use of it for irrigation and power production. Okay, so far we've looked at how climate change has already altered rainfall in the Southeast. These maps show the predictions for changes in rainfall in the U.S. near the end of this century. These are from the RCP 8.5 business as usual model for greenhouse gas emission scenarios. In general, this projects even further intensification of the patterns we just saw. Falls and winters will be wetter, springs and summers will be drier. Across the region, changes vary from little to none, all the way up to a 15% increase. Obviously, this will affect agriculture, water supplies for cities and industry, and will affect the ecology of our ecosystems, especially wetlands and rivers. There's another aspect of rainfall to consider, and that is how much rain is delivered over time. When a lot of rain falls over a short period, soils become saturated and are unable to sponge up more water, and the result is flooding. In urban areas, we've paved over our soils and stormwater systems can become overwhelmed with rainwater, and streets and neighborhoods can flood. Let's look at how climate change has already affected this in the Southeast. In the graph at the left, we see the number of days per year when we get over 3 inches of rain for the period of 1900 to 1916. These are considered extreme rainfall event days that lead to major flooding. While there is some annual variation, the trend is for an increase in such days since the first half of the 20th century. The map at the right shows the geographic data for 3-inch days, where dots are individual weather stations where rainfall is measured. The trends clearly show that we are seeing more and more of these high-intensity rains. Okay, that was a historic trend, but what about the future? This map illustrates areas that are expected to see an increase in rainfall intensity by the end of this century. If we zoom in on the southeast, we see that we are expected to see a continued increase in days with abnormally high rainfall intensity. The greatest concern regarding these high-intensity rainfall events is flooding. Flooding is increasing in Birmingham, throughout the southeast, and across the U.S. Flooding causes significant amounts of economic damage and disrupts the lives of many people. And as you can see in the graph, flooding causes many fatalities each year. Mostly when people try to drive through flooded streets and are swept away. Don't ever try that, please. The picture at the top right is from the flooding that devastated many parts of the Midwest in summer 2019. The Southeast was hit hard by heavy rains and flooding throughout the first months of 2020. Water availability is critically important, not just for survival, but also for sustaining agriculture and industry. And one of the problems we are already seeing from climate change is that water availability is on the decline. Here's why. Rain that is absorbed by soils can stay in soils for days to months. Some of that water seeps downhill and feeds into streams and rivers or aquifers. Some of it is taken up by plants as they conduct photosynthesis, the process known as transpiration. The rest evaporates directly from the soil into the atmosphere. The combination of evaporation and transpiration is called evapotranspiration. Evapotranspiration increases with rising temperatures. This should be common sense by now. The warmer it is, the faster water will evaporate. But also, the warmer it is, the more quickly plants can do photosynthesis. As you might be anticipating, as the climate warms, evapotranspiration is increasing, which means that there's less water left behind for streams, rivers, aquifers, and for farming. Even though the Southeast is going to receive more rain during the course of a year, because of warming, less and less of that water will be available to us because it is lost to evapotranspiration. This graph and map show forecasted trends in water availability through mid-century. The graph at left shows the overall trend for the region and shows that the region is likely to see a decline in water availability. The map at the right shows that water availability varies by geography. While the East Coast states will see, in general, increases or very little decline in water availability, states like Alabama, Tennessee, Kentucky, Mississippi, Arkansas, and Louisiana will see declines ranging from 3 to 6% or more. The farther west a location is, the greater the decrease. Again, while a few percentage points may not sound like a lot, this will have significant impacts on the region's agriculture and economy and ecology. Related to declines in water availability is that the Southeast is expected to see more droughts and stronger droughts than in the past. Droughts are prolonged periods without rain. During droughts, soils dry up and streams and rivers drop in volume, and some cease to flow altogether. The Southeast is naturally prone to droughts, but the droughts we are experiencing today are more frequent than last century, and they strike faster. Droughts are crippling to agriculture, and during them, we often get heat waves. When droughts go on for more than a few weeks, water supplies can get critically low. Atlanta is particularly vulnerable to this because it doesn't have access to aquifer water. Birmingham is also at risk. This is a photograph of Lake Purdy, the primary reservoir for the metropolitan area Water supply. The photo was taken during the 2016-2017 drought. Normally, all the exposed soil would be covered by several feet of water. I've saved one of the most dramatic threats of climate change to the southeast for last. Hurricanes are a natural phenomenon for the region. And let me be very clear, there are no data to suggest that hurricanes are increasing in frequency. However, they are increasing in their destructive power. Hurricanes are already larger in size, and wind speeds have increased. We are now seeing more Category 4 and 5 hurricanes than in the past century. Hurricanes are also delivering more rain than in the past, which is another measure of their strength. More rain means more flooding on the interior away from the coast. Floods caused by rainfall can be both destructive and dangerous in the interior of the southeast. Finally, hurricanes are moving more slowly as a result of climate change. This means that they do a lot more damage than in the past, when they would blow out in just a few hours. We saw this in 2019 when Hurricane Dorian spent several days over the Bahamas, causing epic levels of destruction. Because hurricanes affect such large areas, when they make landfall, the economic impacts are huge, frequently totaling in the billions of dollars. Recovery is a long, stressful, and costly process for the people and communities along the coasts that are hardest hit. This covers the major impacts that climate change has had on the Southeast so far, and the changes that are predicted in the coming years. But before we finish, I want to review some of the societal impacts that climate change is causing. Unfortunately, there are many. Climate change is forcing people to move away from areas that become uninhabitable due to drought, flooding, and in some cases, heat. This is happening in many regions of the world and has begun here in the US. The increasing severity of climate extremes is impacting the safety of people who work or spend time outdoors. As I mentioned earlier, there are many health impacts of increased temperatures, including heat-related illnesses, increased disease spread, and declines in air quality. Increases in climate extremes also increase the cost of living as we pay more for agricultural products, water, and power, all of which are affected by climate change. Importantly, I want you to understand that climate change is having a disproportionate impact on the poor, both here in the US and throughout the world. For example, the poor are less able to afford the higher costs of living that come with these changes. And because the poor typically have limited access to healthcare and healthy, affordable food choices, they often have many pre-existing health problems, such as cardiovascular disease, that make them especially vulnerable to heat-related illnesses and declines in air quality. Due to continuing inequality in our society, climate change is impacting people of color more than whites. This is also true globally. Just as we saw higher death rates of African Americans during the COVID-19 pandemic, we are seeing communities of color bearing the worst of the burdens of climate change here in the US. It is disturbingly unfair that it is the affluent lifestyle of the world's middle and upper classes that have caused the climate crisis, but the world's poor are bearing the worst of the impacts. We'll explore these issues in more detail in another session.